Okay, good morning, good afternoon, and welcome to our next virtual IoT meetup. I'm Ian Scarrett from the Eclipse Foundation. Unfortunately, Benjamin and Roxanne can't be with you today, but we've got a great speaker. I've been looking forward to this meetup for a while. Unfortunately, this is our second try. I think we had a bit of problems last time at Kilton, so I think we're set now. So Kilton is here to talk about a new project called Eclipse ioFog, and it's really about how to get the whole microservices approach to the IoT edge. So Kilton, I'll turn it over to you, and I'm looking forward to it.
Thanks, Ian, very much. Okay, so what I'm going to do is I'm going to show an example of microservices running in Eclipse ioFog, and I'm also going to do a short PowerPoint presentation just to talk about why microservices and why fog computing is evolving the way that it is. So the first thing, let me share my screen here, and if I'm correct, we have a bit of presentation, and then we're going to have some time for questions too. So, okay, let me go ahead and share whole screen. And now, what we have here is, so if you log into this thing called the fog controller, what you get is you get a visual interface that allows you to kind of build some fog computing applications or IoT applications that are made of microservices. And here what we actually have is we have a stream that is grabbing some temperature information and just making it available as a JSON REST API output. And as you can see here, when I refresh, the message IDs are changing and so on. We're constantly rolling information. We'll do some more with this in just a moment. But to get to this point, what you want to do is you want to create yourself an edge processing environment called the fog, and we're going to do that. And then we're going to look at how microservices are built and how they're assembled together. So, okay, first things first, let's go ahead and take a look at this this presentation here. So, okay, and what we're going to do is okay. So we'll just look at this for a few minutes, and then we'll go and build something. So, fog computing, in essence, it's just a matter of running code in a physical space, but you still want to control it as if it's the cloud. So it's kind of the best of both worlds, all of the control and flexibility of the cloud, but you have these on-edge or in-environment processing systems going on. So there's some key reasons why you do this. There's, in some cases, absolutely no other way to connect devices. And this is, kind of the case for something like a legacy piece of equipment that talks on a serial port. So you'd add some fog computing in order to be able to talk to that, and then the fog computing can talk up to the cloud and the rest of the Internet of Things. But also really important is low latency, and you don't incur any cost for your edge processing. You fully own it. And maybe you want to choose particular hardware that's right for your use case, and so in the situation, you'd add some fog computing that is, maybe the hardware is ruggedized for your outdoor application and so on. Other key reasons is privacy and security, because you can keep data on premise. So pretty typical is legacy stuff. And sorry, it sounds like we have someone on. Could you mute perhaps, whoever's got the background noise there? I don't know if that's you, Ian, or. So pretty typical use cases: connect legacy devices, and very common is to add Bluetooth. When you really think about it, Bluetooth devices or Bluetooth low energy devices there's no way for them to talk to the cloud without some sort of edge computing. Thing is we've actually had a sort of fog computing for many years in the form of smartphones. Because you would use a mobile app to talk to the Bluetooth device and then talk to the cloud. So there's an example of kind of the precursor to edge computing or fog computing. Keep data on premise. You can run some real-time stuff right near the data. And with fog computing, you can manage and remotely debug and update. And you can finally do some real interoperability and real integration. So this the Eclipse ioFog, so it runs today, the current version runs on Linux, and that's all popular flavors. And you know, tomorrow it'll have more. It'll be in more places. The same fog. It's fully distributed, and you can basically run it on anything that's got minimum capabilities like this. You just need some space for the containers. You just need about a gig of RAM will do. And because it runs with Docker, you're going to need a 64-bit processor. Which basically this is like a Raspberry Pi 3. If you've got that, you can go ahead and run the ioFog. And what you get with it is building in for the fog is now very, very similar to building for the web and very different than machine-to-machine era building for the edge. What you get is you have a high-performance message bus that's right there for you. We're going to take a look at what that looks like to attach to that. And you can put config into the containers at runtime. You can remotely debug. There's some common logging. View the data remotely. And if you're building with Bluetooth, you can use a REST API to build your or to talk to Bluetooth there in your container. So a couple of reasons why we're doing microservices and why this architecture is on the rise. It's reusable and shareable. So once you build a microservice, you can kind of use it in many places. You get good separation of logic there. We'll look at that. It can run on any ioFog instance, and you can package the libraries and stuff you need with it. And microservices can be fed the information they need, such as SSL certs, at runtime, and you get to use any language. We'll be putting them together using Docker. And the ioFog resources that I mentioned are available to all the containers. And with this message bus, you can go in between containers, and that's how you kind of segment them, and use this fog controller to stand them up and take them down dynamically. We'll reference this diagram as we go through, so I'll just keep it up here. Okay, so back to it. What's really happening here? Well, everywhere, I should say, everywhere you see reference to using the word fabric, it's becoming fog. The version with the renaming is being published. But so if you're watching this in the future, just translate for yourself there. So first, what I want to do is I want to set up my edge processing. And so here I have an x86 instance of the fog, and you know, let's just pretend that it's part of a building here, and it's I've named it West Wing 15th Street. Well, here I have the actual Linux instance that corresponds to that, and so to install the fog on here, it's very, very simple. It's just really a matter of doing this. And so these packages are ready. And so once you've got it, and now bear in mind the old version was named ioFabric, so you're going to see commands with that in it. So I can check the status, and I can get some information about this fog compute instance and so on. And I've tied it up to this here through a provisioning process. And we're going to go through this provisioning process, but basically you generate a key and you attach. So what I've done is I've taken a real-world compute instance, and then I've tied it to my fog, and that means I can control it. Well, let's take a look at what's running. We've got a couple of containers here, and these correspond to what I have running over in the build panel. So this the fog controller here, in this interface, allows you to say what's going to run where. Well, let's go ahead and add one to it. So I'm going to give myself, you know, we just call them a track, which is, you can think of it as like a layout really of microservices. So let's just say here, let's call this one simple demo. Okay, and now I'm going to add a really straightforward container here, just to show you it instantiating it, and we'll call this hello1. And now this container is just sitting in my layout, and it's not actually going to instantiate because I haven't put it onto any fog instance. But I'm going to go ahead and I'm going to put it on this one, and then I have to activate. So you can kind of activate and deactivate microservices schemas at will. And so then let's take a look, and it may take up to 20 seconds or so. And what's going to happen is then all of a sudden this container is going to start running here. So we'll give that just a moment. Make sure I got that in the right place. I do, and I do. Okay. There we go. And so we have the new container that's running. So I'm in essence controlling some edge computing remotely through this, through this fog controller here. So now, what on earth does this container do? Well, by itself, it does, very little, and it's really just there to show a demonstration of the instantiation. But as an example, I'm going to look at what it's like to control the edge environment. Now, my edge environment here with this box is like all compute. It's a combination of the connectivity plus the compute power. And so the connectivity part is I'm going to go ahead and open up a way to talk into this container. And we actually have this capability here that I'm going to show, and then I'm going to explain. And that's this thing called ComSat that's part of the ioFog system. And so what I've just done here is I've just changed the connectivity that's here in the edge compute environment. And what we get now is, as you can see, I've opened up a port. I want to talk to port 80 inside the container that I created, but on the outside, I'm going to make it port 10,000. And I just picked 10,000 because it's a high number and won't interfere. And in another moment here, we're going to see that we also have an additional container, this thing called core networking. Now, that container serves a particular purpose. It goes and it talks up to this thing called ComSat. And now what I'm going to get is I'm able to actually talk into that container that's running here on this Linux instance, and this is what it gives me back. But note that I'm able to talk to it from a regular web browser. So how is this working? Well, let's go ahead and take a look at this here. So each piece of the fog is running on some Linux compute. And as you can see, it's intended to talk to multiple devices, and the devices are kind of separate from the fog computing, as they should be. And they're clearly taking their directions from the fog controller, but somehow I'm able to actually reach in and talk to the container from other locations, in this case, the public internet. And the way that works is, so fog controller, ioFog, ioauthor, and ComSat, they're all different segments of the Eclipse ioFog. And this is a fully distributed system here. Well, you put ComSat anywhere on your network, and it can even be the public internet, anywhere that is visible to all of the fog, the ioFog processing nodes. And then the ComSat facilitates these to talk to each other. And also, in the cases like the one I just showed you, it facilitates opening a port on the public internet to talk into the fog. So you can reach microservices remotely, and we're also going to show microservices coming together from different locations. So let's go ahead and assemble that now. So this is sitting here, and it translates to here. Well, let's go ahead and give ourselves another instance here. And we're going to go grab another bit of compute. And the reason that I'm going to use the Rackspace Cloud instance is because we can all look at it together. If I were going and doing this on like a Raspberry Pi, of course, it'd have to be physically in the room, and it would be a little bit more difficult to show you. So let's take a look here. So let's go ahead and grab this one, and this is a great IP right here, and we'll give another instance. So okay, we're in, and now let's take a look at the status. So it's sitting there running, but it's not provisioned. And I prepared this box in advance, so it has all the basic stuff installed, which is really Java, so it can run Eclipse ioFog and Docker. So now let's go ahead and provision it. So if we go back to our controls here, I want to add a node. And it's an x86 node. So let's go ahead and we'll just call this, let's call this South 9th Street. Sure, why not? And this is just an abstract representation of the processing. And now we're going to tie it to real-world processing. You can see it has some information that's just open. Now with this provisioning key, we go and we attach it right now. Okay, and now when I take a look at the status, you can see that's running and it's got a connection. It doesn't have anything going on. It's very quiet. It's not even using any CPU here. but now it's attached. And so when we go and we look, we can see that we have information about it, and it tells us that it's running and when it last was seen and so on, and that's all good stuff. And I'm going to enable some cool stuff on here too. I'm going to enable like some remote debugging, and I'm going to enable Bluetooth communication on this compute here. So we did that, and now let's go back to our build, and then we'll do some cool stuff here. So if we look now, in a short amount of time, you'll see the containers running. So yeah, we have some stuff starting. There's remote debug, and then there's some of that ComSat networking again. So okay, I have another track here, which is this this building situation. So now on this same microservices layout, let's go ahead and let's add a different microservice, and let's tie everything together. Now, here what I've got going is I've got a source of some temperature information, and this is publishing, and it's publishing onto the message bus. And then I use this line to put it over to this other microservice. And now if we go back and look at our other one here, this is the microservice that's doing the temperature gathering there. And this is a microservice that's letting us look at it as REST API. And the configuration for these can be delivered dynamically, and the fact that they're both on the same edge compute is just a matter of coincidence. Let's go ahead and add another one, and we're going to get this information, and let's go ahead and grab, this is for a different city, change its configuration here, and let's go ahead and let's run it on this new instance that we've got. We'll call this Temp2. Okay, so now when we go back to the other Fog Compute instance here, we can see, and I'll get these about the same size so it's a little easier to understand what's going on. So here, if you recall, we had the remote debugging and the Bluetooth, but now also we'll see come in. There we go. So now we've got some temperature stuff coming in here. And so these two compute instances they can be separated by, well, the entire span of the globe, really. As long as that ComSat piece that you have deployed in your system is visible to both of them, then you get this interconnectivity comes free. So now, since these are in two different locations, what I want to do is I want to go ahead and pipe this one also over to here. So we have JSON output, and I showed you right at the beginning here the results of that output, right? And it's still rolling. But now it's going to actually be receiving the data from two different locations, and these could be separated by, as I mentioned, hundreds of miles or whatever you'd like. And so let's go ahead and see on this instance. There we go. So we have, what happened is the container that we chose to run, which is the temperature microservice, is now followed by a core networking container. And the reason that that's added is because when we drew the line to add this over to this one sits on a different fog instance, right? So this is 15th Street and this is 9th Street. And because they're separated, they get an extra container that connects them. And this container is, you could look at this as kind of the implementation of the talking to the ComSat between these fog nodes. And so that's how that actually works in practice. And what's going to happen here is that we'll get differing information now coming through here. And we have Chicago and San Francisco. And both of them are coming in now to the same location, even though they're completely separate compute instances. And note what we didn't have to do here. We didn't have to write any code to do any internetworking to move the data. And we didn't have to write any code to go to some central cloud and then have this serve it out. This microservice is running on this fog compute node here as this container. These containers are all thrown in there as part of the ioFog, the Eclipse ioFog system, to give you this free internetworking. And so this container can behave as if all of the data is coming to it locally. So kind of the miracle here is that you focus your microservices on functionality, not on moving data from one system to another. And when you write a microservice, you write it to deal with the data at hand and know that you can push it to where it's needed. So let's tune this a little bit. We have a buffer size of 4. What that means is we're going to store 4 pieces of information at the same time. Let's bring it down, and let's actually make it really easy to see. Let's bring it down to just 1. And what that means is we're either going to have information from San Francisco or Chicago, and we're not going to have both because we're only holding 1 at a time. So let's give that a moment to kick in there. And so that looks like the 2. And I'll give it a moment for the 1 to also load in. There we go. And so right now we've got Chicago, and another Chicago, and another. And eventually here, depending on our timing, we get San Francisco, right? And so what we're doing is we're tuning the microservices behavior remotely by passing it new configuration. And so how does this thing even know how to listen for the config, and how does it know what messages to process and so on? And that comes down to the microservices build model. So what you're seeing here is how to run, but let's take a look at creating a new microservice. Okay, so here's a couple that I was just working on earlier. And so to add one here, you just add a new microservice. And this fog controller functionality is intended to work with a container repository that you have on your distributed system. If you'd like, you can use public container repositories, but the problem there is that you probably have a really security sensitive and private deploy. You have the ability to have these point anywhere. Let's take a look at this one. So I, of course, because this is my company repository, I've thrown it in here. And all I have to do is I have to put the container image name. And you set up your fog processing nodes to, let's see here, best way to show this is to take a look here at the info. So we have here some certificates and some directories and things, and you can set up, well, here actually, I'll show. And so you can actually change also the certificates that you would use to talk to the different Docker registries. And you can change the certificate and so on that you use to talk to the different fog controllers. And so here, all I've had to do is give it a name, give it a container image, which is just a string, and I can put in all kinds of other information about it, such as a category, which in this case it's a sensor. And the description will say rotation, heart rate, via a flow energy. Okay, great. And now this microservice here, and I can put an example of the config if I want to help somebody use it. This microservice now becomes available in my catalog here, and you can see that it has some of the information that I put in. And if I want to instantiate it, I can. Let's go ahead and throw this one onto some fog here, and we'll just call this heart 1. And let's put it onto that 9th Street processor there. So if it takes, depending on how frequently you've asked the fog to refresh its processing, it could take 20, 30 seconds, or in some cases, people have been putting them up to 5 minutes because they don't want it to spend a lot of bandwidth doing the communication with the fog controller. So let's see. And let me make sure that I got that right. Put it in. There we go. Yeah, and so now we have this has been thrown in there. So I published a new microservice, and then I went and I threw it onto some fog. So what's it like to build these things? Well, let's take a look at the code of a microservice so you can see what it's like to create them. So here we have a, let's Actually, I want to look at one that is useful for in-stream processing. And let's look at something that does some threshold filtering. And that's a pretty common task. So for all of your code, you're going to package it for Docker. And so that means you're going to use a Docker file. Now, if you're not familiar with or haven't been creating Docker containers, it's actually really straightforward, but it will take a little practice. Once you get it right, it's kind of a piece of cake. So you start with an image that you're drawing from. And in this case, we often use Alpine Linux because it's very small. You want to draw from whatever it is that's most appropriate for you. So if you want to build in Ubuntu and then you want to use Ubuntu in your microservice, just go ahead and do from that. So then there's some commands. And in this case, we're just running some commands to kind of prep this Alpine environment for our Python situation that we're looking for. And so we're going to update Python, and we're going to add in here some, we use virtual environment because we want to get at some host information. And then we've got here, this will be ioFog very soon. And then we're going to use WebSockets as well. And that's because we like real-time data. We create a repository for the code. So in other words, we copy whatever code we've got there into a directory called source. And then we go into source, and then we go ahead and run the single Python file. So this Docker file is something that you could draw from open source and modify it, or once you write it for your own team, you can use it again and again. So what does this index.py, this Python file, do? It's just one file. Okay, so we're going to make use of some stuff. As if you're familiar with Python, you know that you import just the portions of what you need. You don't tend to import whole libraries unless you're going to use all the pieces. So we're going to grab JSON, and we're going to grab here the Fog client and the Fog message capabilities, and then URL library and some OS stuff. So we've got our configuration for the container or for the microservice, and then we've got our message client and our control client. And that's because the Fog gives you the ability to receive your configuration as a control message and update your configuration in real time. And the message client, this allows you to create and publish messages. And that's exactly what this data is these are all messages that are coming through that message bus. And if you recall, the message bus can be distributed with almost zero effort. So you might want to write a container that manually copies data up to the cloud, backend that you're using. That's fine. But this high speed or high performance message bus is distributed. That's really, I think, really unique to fog computing. It's really valuable. So you might want to consider writing your container or your microservice to use it. So, okay, now we go ahead and get our ID from the environment. You will always have your container will always have your ID mapped into the environment variable called self-name. That's a given. In addition, you will always have the REST API resources of the Fog available to you at the same address in every container and at this port here, 54321. So there's documentation available on the Fog services and how to connect to them. So, okay, what do we do to get started? So we'll look at this class in a moment. First, we're going to see how we set up the actual connection there to the message bus and stuff. So we go ahead and get the host, and that's built into this this object here called ioFabric, or soon ioFog, and that's an SDK that we give you in Python. We have one for there's one available for Node.js, one for Java, one for Python, and more coming all the time. And all this does is this takes away some of the work for you. It's all REST API stuff and all well documented, but instead of you having to build it, you can just use an object. And so my listener is going to be a listener of the Fog, and the client is set up just like this, and my container ID is what I got up here that I got from the environment. And the reason I have to report that in is you don't want anybody grabbing messages unless the container has been instantiated properly. So if you don't have your container ID, which is what's delivered through the fog, you're never going to be allowed to connect and sniff. You can't get any messages. You can't do anything with the fog unless you were authorized to be part of the fog. And that authorization, of course, occurs through this whole process here. Similar, I'm going to get my control messages through a different socket here, right, or a different REST API resource. And so the URLs are different because the API is different here. So, okay. Now let's go ahead and look at our object now that we have those. So for the object here, which is the fabric listener here, or soon to be called the fog listener, on connected, what I'm going to do is I'm going to go here and I'm going to get my configuration right away. And on my response here, if I don't have config, no big deal. I'm just going to call my own method here on update config, and I'm going to call it with none. Okay, no big deal. So I have no config. But if I've got something, I'm going to grab the config out of the message there that I got, and as a response from this call here, config get, and I'm going to set the config. After I'm connected already and I'm getting control messages, then I'm going to define like what happens on update config. Okay, if the new config is not null, then I'm going to go ahead and I'm going to set my config to it. That's simple enough. On closed, I'm done. So just return. And then on message is where we do really our work. So on message is going to be available to anything that you build with this Python SDK. And so I'm going to call my method filter message and pass a message along. And then new message is the return value. And if it's not null, then I'm going to go ahead and I'm going to send it onward, which means on the message client, send that message, and that's going to publish it to the bus. So what do we do to filter? Okay, so I'm given some configuration such as the threshold direction, like above or below. Is it inclusive for the numbers that have been put? And then what's a threshold value? So let's look in config and see if we've got threshold direction. And this is the type of config that we see here that gets mapped at runtime by the person who's using the microservice. And so they're going to set the threshold direction. It's going to be either above or below. And then if inclusive is there, then as a Boolean true, then we're going to make it inclusive, and then we're looking for the threshold value. So if we're above and inclusive is true, in the message that we just received, the content data is the actual data value that's being passed. And if it's greater than or equal to the threshold, great, let's return the message and pass it on. Because when we return this, it's going to be sent onward. It gets put back on the bus, so to speak. It's a very quick calculation. As you can look through the other situations here, the other conditions, if we're not inclusive, then if it's just greater than, and then if it's not above, then we're doing below, and then we're going to look at less than, and so on, and we're done. If we have an exception, the message comes back null, which means that we're not going to send it onward, because we're looking for not null before we send a message on the bus, put the message back on the bus. So this one file here, written in Python, is an entire threshold filter that can be used with any numeric data. That's a very valuable microservice to be able to reuse. And if you want to publish it to your team, you can go here. You can check that code in, create a Docker container from it. Then maybe you want to set the thing here, and let's just say it was threshold 1, threshold v1. Great. And that'll do it. And so now this becomes available, and let's call it here. Now let's just call it threshold filter. Great. And we want to assign a different image to it at the moment. So now it becomes available, and I can use it, and I can stand it up. Now, that container is not something that we checked in. I think we're a little too short on time to go and check in a container that we build raw, but I'm going to show what it is to build and check in a container that's already, where the code's already in place. So let's take a look here. That's my root, and now I'm back at my home. Okay, great. So let's look at something that's going to do heartbeat connection and measurement. So I've got my Docker file and I've got my Python file. So all I have to do to check it in is use Docker build and then tag it. And in this case, the company system here, catalog, and let's call it heartbeat. We'll call it heartbeat webinar 1. And then the dot here means use the Docker file that's in the local directory. Okay, and off we go to build. It built so fast because a lot of my components have been pre-built on this machine as I've checked in code. And I just want to do Docker push. And I've got the container local. It's going to be the same thing. Off we go. And so I'm going to remember that because I'm going to go use it over here. And we'll wait for it to finish publishing. There we go. Container's pushed. And so now let's go back here. And we'll go ahead and use this one. Instead of the fake one, we'll use the one that we actually just pushed. And thought we had renamed this. And so instead of official, we actually ended up doing heartbeat. So let's just call it heartbeat webinar. Great. Okay, looks right to me. So now let's go ahead and instantiate that. So we checked in a container. That means it can actually be run. And we published it, which means now that's for use in our fog. And let's go ahead and throw that on. And let's run it on the 9th Street fog. And we'll just call this cool. And we won't bother with any config or anything. So I think we're at the last couple of minutes before we open the Q&A. So let's go down here and take a look. And there it already came up. So we've got now the container that we just pushed to Docker is now something that we can throw on as many pieces of the fog as we have control over. Let's go ahead and create another one. And let's go ahead and put this one, we'll call this webinar container 2. And let's go ahead and throw this one on the 15th Street. Okay. And within a short amount of time, we will also have it up on this instance. This one we didn't catch at the lucky timing. So we'll give it just a moment, and it'll stand up. Pardon me. There we go. And same container. Same container image, and it just stood up. And so there we go. So now we're reusing that container that we just published and making it available to all of the fog and throwing it wherever we want. So cool. And let's check in on our weather here. And as we roll through, we're still trading out the messages. Everything that we had running is still running here on this track. And if I want, I can go ahead and I can go in and add stuff onto a different track and so on. And so I think that's about good there. Shows an example of what it's like to write a container, an example of what it's like to build and publish a container, what it's like to provision a couple of instances of the fog, and create your fog here and coordinate what's running on it, and what it's like to put together a couple of microservices to give you an output that is something that you can go ahead and start tapping into and use. And I think it's probably a good point to open it up for Q&A.
All right, so I think I'm actually back. Hello, Kilton. I think I fixed my internet issues. Can you confirm that?
Yeah, it sounds great, Benjamin.
Awesome. Thanks so much, Ian, actually, for stepping up. We were chatting about your demos, which I think we both enjoyed very much, and also chatting about some of the questions that we've seen on the YouTube chat channel. So before I actually ask the few questions we already have, I want to remind you guys that you should feel free to use the channel to ask the question, or if you're on Twitter, you might as well tweet using the virtual IoT hashtag. We'll make sure to ask Kilton the question. There is an interesting question regarding kind of the visual flow programming tool that you used. It seems similar to Node-RED to some extent. How would you compare the kind of functionality that one can achieve with your visual programming tool as opposed to Node-RED? I guess, well, yeah, there's certainly a bunch of differences there, right?
Yes. So that's a good question. Thank you. So Node-RED is, of course, by its nature, focused on Node.js, but also the visual layout is pretty much where the similarity ends. What you're doing with the ioFog and this visual tool is you're just doing a microservices schema, but the controller, the fog controller that's behind it, is it has its own REST API, and so you could actually do all of that via command line, or you could do all of that programmatically, or you know, I mean, you could write code to actually instantiate containers and so on. So you know, the visual layout tools similar to this, they're you know, you can look at something like SPSS, or you could look at Node-RED, right? And they attach one module to another, draw an arrow between them. Is although it does look similar, the functionality is quite different there. So I like Node-RED very much, though, and in a lot of ways, Node-RED and ioFog are both good examples of a microservices and segmented logic approach that the world is moving toward, which is getting away from having code that's compiled with all of the other code in the stack and moving toward being able to segment your logic for reusability and so on. So in a way, you might even say that you know, Node-RED is a really good visual interface example of what you would do to control the fog.
That's right. Yep. So yeah, again, please remember everyone to ask questions on Twitter. I actually have one. I think, I mean, you mentioned a couple times that the Eclipse ioFog is essentially an open source project. Can you briefly give an update on kind of what are the next steps for the project? How can people use ioFog today, or when can will they be able to use it, and what's kind of like your immediate roadmap for the project?
Sure. So the project is it's fully functional and complete, but what hasn't been done is so we need to publish a version that is actually available in. We need to publish that first version that's actually available in the Eclipse repository. The packages will be updated, and so the package install is going to be the same. We don't want anybody to have to download and build directly on their Linux version. We want them to just be able to use a single command to do the install. Publishing some new packages there that are ioFog, and that's pretty much the only step that remains there for the fog controller to make it distributed. You know, so to allow you to install it on your system. In about a couple of months, we'll be releasing the first version of the fog controller that you put on your WAN or your LAN or the public internet, right? It's up to you to lock it down, just the same as, you know, any web server or anything like that. That'll be coming in about a couple months. The ComSat is already available for distributed use, and so we'll be launching that shortly after the first version of the ioFog is available on the Eclipse repos.
In Kilton, how do you see people kind of participating in ioFog beyond just kind of certainly helping you with the core code? But is there an ecosystem that you envision around this?
Absolutely. So I'm going to give some great examples of what some wonderful individuals are doing out there in the world. One good example is if you have a language that you love, maybe you're a big fan of Go, or you really just prefer to work in C++. Maybe you want to take some time to write an SDK that everyone can use and include in the projects and contribute it into Eclipse ioFog that does all of the REST API calls that talk to the fog services. It's just really handy, and if you love the language, you're probably the best person to write the SDK because, for example,
Right.
the Python SDK is Pythonic, as they say, right? And the Java SDK it's very familiar with listener callbacks. It's very familiar to Java developers. The best thing is to have native developers building it. Another example of contribution is, we have someone who is very fascinated with and has been working with unikernels. And that's kind of an alternative to Docker containers, or you could call it an evolution of. And her promise has been that she's going to be committing a branch that allows you to use ioFog with unikernels.
Cool.
And so let's go ahead and experiment. Let's expand the capabilities beyond this starting base. And the fog stays universal, and the capabilities keep getting stretched and expanded. And I myself have a version that I'm looking forward to publish that runs on smartphones, so that you can take advantage of these great ARM processors right there on your phone.
Right.
Yep.
There's another question from the chat. Do microservices have to communicate using the messaging bus?
They do not. You can. So the messaging bus is optional. The remote config is optional. If you look back at that hello web, that silly container that just gives the message, hello world, grossly misspelled for fun, that container is what I would call a very selfish container. It doesn't talk in the message bus. It doesn't do anything except instantiate it on the fog, and then it does its own business.
Right.
If you prefer, you can write microservices that maybe you push them an API key or an IP address of your cloud backend, and maybe some credentials and maybe an SSL cert. You push that that's why you would want to use dynamic config. But aside from that, you could just have it gather some data on the edge and talk directly to your backend, and you're done. So now for you, the fog has become a remote management, deployment, remote update and debug environment in which you can instantiate code that maybe you've already written that you would like to package as a microservice.
Interesting. Okay. Any other questions on the chat?
Yeah, I think we're probably getting to the end. Maybe a few general announcements before leaving you guys. And the next virtual IoT meetup is going to be November 2nd. I think, Ian, maybe you will be hosting that one, because I'm going to be presenting our Eclipse IoT ecosystem, which is something I think we haven't done actually ever on virtual IoT. We always talk about open source for IoT. We like to invite our Eclipse projects to speak in addition to other cool open source projects. But yeah, we're going to take a few moments to talk about what's hot at Eclipse IoT around programming, constrained devices, gateways, all the way to the cloud. We really have lots of stuff going on. You may have seen the white paper that Eclipse IoT has published in the past few days. So I will be very much looking forward to that one. Again, if you guys want to participate, as in presenting, just like Kilton did, and I think he really did a great job. Thanks again, Kilton. Just ping us. You can email us via meetup.com if you have topics you would like to cover, or at least topic you would like to see covered, and you don't know, you're not capable to do a talk, but at least you would like to see the topic. We'd like to know. Please give feedback also on Meetup about what you liked, what you didn't like. You can evaluate our Meetup group. We certainly appreciate your feedback. And yeah, this was me talking for one or two more minutes, but we still don't have further questions. I think this was all crystal clear, and if people are watching the replay of the webinar, feel free to comment on YouTube. We'll make sure to forward your question to Kilton afterwards. Yep, Ian. Yep.
Are you going to talk about the draw? You put something on the chat about the draw. Are you going to talk about it?
That's correct. In case you guys are not following the chat, thanks for reminding me, Ian. I think Kilton has a great dev kit for ioFog that's based on, how do you call it again? The Blue Pi?
Yeah, we call it a blue box. So so these, we have a little fog computing dev kit, and it's based on Raspberry Pi, and so that means you can kind of plug it in or even give it a battery power supply. And the reason it's called a blue box is because the Raspberry Pi 3 has integrated Bluetooth, and Wi-Fi. And so these little boxes are a great way to start putting fog computing into your physical environment. Some examples I've seen is turning the office, the office space into a Bluetooth enabled fog computing environment. And then you can start talking to devices that are around the desks and so on. But in serious cases, it actually has been in hospital rooms or in warehouses. And so this dev kit's a great way to get started. And so I think that's the winner of the raffle here is going to get sent a nice dev kit.
Well, pretty awesome. Thanks for basically offering this dev kit. So yeah, I've posted a link on the YouTube channel. You basically have one more, like 15 extra minutes to enter the challenge. It's really for people who were watching live and who engaged, just like many of you guys did, and thanks for that. So yeah, there's a Google form. You just put your name and email, and you get a chance to win the Raspberry Pi. So that's yeah, something we're very excited about. Thanks again, Kilton, for that, and thanks for the great presentation. I learned a lot. Again, about ioFog. I think you will be posting your slides somewhere, maybe on SlideShare, and we'll share the link with the participants. And yeah, thanks all for joining. Thanks so much, Ian, for saving my back here. That was very much appreciated. So thanks all, and we'll be back on November 2nd in 2 weeks' time. Bye bye. Take care.
Thank you.